Okay, good morning. Welcome to KUB314. We're going to talk about how to run Gen AI workloads on EKS. I assume many of you in the last couple days have been to the keynotes. I think Peter was Monday night, Matt was yesterday. I just heard there's a machine learning keynote going on as we speak, so thank you for coming to this talk. In many of those keynotes, they're talking about machine learning, generative AI features that are coming out, Graviton 4, Trainium 2, Ultra servers, all of this cool stuff. And I think a lot of you in this room are saying, yeah, that's great, but I can't use it unless it works with EKS. And a lot of customers, some of the largest foundational models out there, you see a lot of them were trained on Kubernetes. And that's exactly what we're going to talk about today, is the work that EKS does to make running Gen AI is in the title, but really any machine learning workloads easier to do on EKS. And I'm joined by Rama, who's going to talk a little bit about why EKS and Kubernetes has become a good fit for ML workloads. And then special guest, we have Kaz from Eli Lilly and Company, who's going to talk about how they've built their machine learning platform on EKS and the success they've seen. Okay, super quick, why generative AI? What is generative AI? I know all of you probably know this. Maybe some of you had a late night. It's the first talk. I'll go super quick here. AI that can produce content that looks like human content. In a lot of cases, you can't even tell the difference. And it's powered by foundational models that have up to several hundred billion parameters, probably by next year approaching trillion parameters. And the real innovation with generative AI is that you can reduce the time to build ML applications, because you start with these huge foundational models, and then it takes only a little bit of training to fine-tune and do what you need to do for your specific tasks. As far as use cases go, really 4 main buckets that we've seen for generative AI use cases. Probably the one you're most familiar with is the enhancing customer experience. I think Andy came on stage yesterday and was talking about Rufus, the new agent that can help you shop on Amazon.com. Boosting employee productivity is another one. Another few announcements yesterday we had were code migration tools. I think we talked about at Amazon how we've saved, I don't know, X number of developer hours moving from Java 11 to Java 17. I think we also announced a Windows modernization code migration, so that's a use case we see a lot. Content generation, image generators are cool, video generators are cool. And I think the more interesting one is business operations. I've had a lot of customer meetings in the last couple of days, and a lot of you are already using Gen AI in some of the platforms you're building, whether it's doing log analysis to do faster troubleshooting, onboarding your developers faster to the platforms building. So we're starting to see some use cases that are actually working. Some of the trends we've seen, more complex generative AI workflows, agents talking to agents, moving to production models require guardrails, other sets of capabilities. And I think the last one is the most interesting. AWS, you've gone to the keynotes. AWS has a lot of different tools. Bedrock was talked a lot about yesterday. Amazon Q. We have a lot of different layers of the stack. EKS is towards the bottom of that layer, where you really need the most flexibility, the most customization, the highest levels of scalability. But I imagine in a large enterprise, you might be using a mix of EKS, Bedrock, Q, other tools. If 2023 was the year of Gen AI proof of concepts, POCs, we've seen 2024 be the year of production. And moving to that production mindset really requires a different way of thinking. You need to start thinking about how are we going to make money or save costs? We can't just run POCs forever. And you start to think about cost of inference at scale, latency at scale. You may just not want to pick the highest performing, best model. You need to weigh that against how much is it going to cost me to run that in production? What is the latency? How is it going to impact the user experience? And then when you move to production, you also need to think about things like security, compliance, ethical constraints. So there's a lot more effort that goes into building a production application, and that's really the trend we've started to see this year. So I'm going to hand it off to Rama to talk about some of the generative AI challenges and how EKS helps solve them.
Thanks, Mike. Hey, folks. Good morning. I'm Rama Ponuswamy. I drive worldwide go-to-market for AI/ML on EKS. So, talking a little bit about some of the common challenges that we see our customers face when they start to scale their Gen AI workloads in production. It's sort of along 3 different buckets, right? Like, as Mike was saying, there are different needs for your different teams within a single organization, and one model is not going to fit all of them, right? So more than likely you will have to run multiple models, different ways of customizing those models to fit specific needs of different teams. So that comes with the added burden of day 2 operations. How are you going to manage the versioning of those models? How are you going to upgrade these models when new models show up? How do you build guardrails against these models? And how do you manage access to data for these models? Because customizing these models is not going to be easy. Customizing models requires specific curated data that is domain specific and fits your particular specific use case, where you want these models to be able to drive tasks specific to that domain, right? And that also means that you are having to integrate multiple data sources, having to manage access to all of this data, all while maintaining your data security requirements. And last but not least, all of this means that you are having to manage massive scale of infrastructure, which gets trickier. We have seen a lot of our customers, when they start to scale or hit critical scale in their production, they start to feel that delegating more of your infrastructure control makes you less capable of controlling any of these parameters. Right, so we start to see customers, as they hit some critical scale in production with GenAI workloads, they want to have more control over their infrastructure and start looking at options like EKS, where they can get that necessary control to be able to customize all of their models and the ML environment that they want to operate in, and to be able to optimize on their cost to meet their ROI targets. So those are challenges at the organizational level. Let's think a little bit about what are the challenges of a data scientist or an ML engineer on their day-to-day operations. Data scientists don't really want to be managing infrastructure. All they require is a readily available infrastructure that they can just go deploy their model and scale on. And they don't really want to be doing boilerplate code or scripts that they need to run in order to manage the life cycle of their ML models. Instead, they want a readily built platform that can help them with all of those capabilities that they need to effectively deploy and scale their workloads going further as well. And they want to be able to meet these requirements in a more optimized manner, in a repeatable way that they can just keep doing it over and over again, instead of having to build something in a very individualistic ad hoc manner each time they need to build and scale a model. So to summarize in terms of the key challenges or considerations, if you will, in terms of deploying generative AI in production, it's along 3 lines, right? You want to be able to move fast. You want to enable your data scientists and ML engineers to build their models fast, deploy them fast, and be able to scale as they go forward as well. And the second thing is about how do you enable customization of your models, right, at scale. You want to be able to customize multiple models to fit specific use cases within different teams in your organization. And you also want to be able to ensure that these models will be able to scale, not just to meet the demands of today, but seamlessly scale to meet the demands of the future as well. And how do you ensure that you are able to continuously optimize on your costs as you're hitting higher scales going forward, scaling up your ML models as well. So this is really where we see a lot of customers mention that EKS makes a lot of sense for them, especially in environments where they need a lot more control over infrastructure to meet data security concerns, to meet cost optimization concerns, because they need to hit the ROI targets, so on and so forth as well. So let's sort of dissect, where does EKS provide these benefits? Why do we see a lot of our customers start to leverage EKS for deploying their generative AI workloads? It's again along those buckets of how does EKS enable you to move faster? It's twofold, right? The first is, in most cases where customers already have standardized on Kubernetes as the way to do their application development, they get to just extend that existing platform and deploy ML models on top of it, because they've already built foundational capabilities that they also need for their ML workloads. The second reason is availability of open source tooling. Right? ML space in general is fast moving, and a lot of those innovations are happening in the open source arena, right? And these open source tools, most of them usually come with out of the box Kubernetes integration. So with EKS, customers can just integrate that ML-specific OSS solutions on top of it, and enable their data scientists to just move faster by providing them all end-to-end MLOps lifecycle capabilities. As we saw earlier, that's one of the key challenges. And in terms of scalability, Kubernetes and EKS as such provides native integrations to all of AWS ML infrastructure services, enabling you to continue to scale seamlessly as your demand increases for your ML models as well. In terms of customization, because you're getting control of your entire infrastructure right up to the instance level with EKS, you're able to flexibly configure your environment to suit your specific unique needs, and you're not going to be restricted because of a certain feature that we provide. And we don't have restrictions in terms of how you can configure your ML environment within EKS. So that enables you to customize it to your liking, to suit your specific unique requirements. And because you're able to have multiple choices in terms of instances, you're constantly able to choose the right infrastructure sizing, the right instances, and be able to optimize on your costs continuously as you start to scale further with your ML workloads as well. So let's go a little deeper on how does flexibility and cost optimization work on EKS for ML. It's really across 3 layers. The first is at the instance level. Because EKS supports all of the EC2 instances, GPU, NVIDIA-based GPU instances, Trainium, Inferentia, Intel-based instances, so on and so forth. Any EC2 instance that is available on AWS, you can leverage it with EKS. So that lets you choose flexibly which instances you want to use based on the workload and based on the requirements of the workload. So this is not just going to be enough, right? Like ideally, you don't want to be making these choices manually each time a new workload comes in for scheduling. And that's really where the power of Carpenter comes into the picture. With Carpenter, you can effectively automate all of these choices by providing it the parameters under which you want to provision a specific instance and make it evaluate the incoming workload to choose the right instances for it. All of this gets automated by Carpenter, and it's repeatedly doing this on your behalf whenever a new workload gets scheduled. And on top of that, Carpenter makes provisioning much easier as well. So Carpenter, along with our EKS optimized army, comes with all of the inbuilt dependencies that you need, and you are able to quickly spin up instances whenever your demand goes up, and Carpenter gives you fast scaling, but more importantly, it also scales back down whenever your demand is not going up. So you are able to cost optimize on that front, and you are also able to leverage GPU sharing mechanisms, and with the built-in multi-tenancy of EKS, you are able to effectively share your constrained GPU resources securely across multiple teams in your organization, shooting up your utilization of GPUs further as well. And on top of that, you get to integrate OSS, ML-specific OSS solutions. There are a whole ocean of solutions available out there. You get to pick and choose the right tools for the right functionality that you need within your organization to then integrate it with EKS and get all the flexibility you need with the ML-specific functionality your data scientists desire as well. In terms of, I wanted to quickly highlight very few customers. We have a lot of customers running GenAI on EKS, but I wanted to pick a select few that have been able to reap certain benefits by deploying generative AI workloads on EKS. Vanavar Labs is a defense tech startup. They supply unconventional intelligence to national intelligence agencies and defense departments, so they operate at the highest level of secrecy and data security concerns. They were able to utilize EKS and Ray and Carpenter together to achieve 45% reduction in their inference costs. And they were able to do this by using mixed CPU and GPU instance types and being able to schedule CPU heavy workloads on GPU instances to utilize the underused CPU within the GPU instances. So overall increasing their GPU utilization by a huge margin. And we have recently published a blog with them. If you're interested in learning about the specific configurations that they did to achieve this cost cut, please feel free to check it out in our AWS Containers blog channel. The next is Informatica. They are another customer that have built an LLM ops platform to train and fine-tune multiple LLM models on top of EKS. They were able to achieve around 30% of cost saving compared to managed services that they were using earlier, and they were able to achieve enhanced configurability because they were sort of constrained by the managed services customization ability that the managed services was providing them. And Zoom is another customer that has been able to create a similar LLMOps platform where they do multi-model hosting, and they're able to reliably and efficiently scale to meet their ongoing demand as well. Another key customer I wanted to highlight is Hugging Face. If you have used the Hugging Face Hub, the freemium pricing one, the free tier one, that basically runs on top of EKS today. So the challenge that they initially, when they started out building that platform, was they had to build a platform that would enable inference of millions of models with dedicated inference endpoints, and a lot of different AI domain apps had to be hosted there as well. And all of this needed to be provided with free tier pricing. So it was a challenge that they had to hyper optimize on their cost, on their infrastructure cost, in order to be able to afford to provide this as a freemium price tier as well. So the solution they've taken is to deploy it on EKS, multiple EKS clusters, 2,000 plus nodes, and they're able to effectively bin pack a lot of pods within very fewer instances. And they're also able to use time sharing with GPUs, where they swap models in and out every few seconds as well. And with this, they are effectively able to provide this platform across the world for ML developers to collaborate on. So I mentioned something earlier, customers that already have Kubernetes as a standard platform for their application development. This is sort of a snapshot of how those platforms look like, right? They build all of those foundational capabilities already into this platform, like how to do logging, monitoring, disaster recovery, security at scale. All of those challenges have been solved. And customers, when it comes to ML, they don't want to again solve these challenges or reinvent the wheel, right? They just want to use all of these foundational capabilities and extend it to run ML workloads on top of this as well. So that's one key advantage. The second advantage is customers are able to use Kubernetes as the standard layer across all of their environments, be it on-prem, be it in the edge, be it on cloud as well. So using Kubernetes helps them unify these operations. And if you have been paying attention to the recent releases we did last Sunday, we released EKS hybrid nodes as well, making this much easier for customers to do. With EKS hybrid nodes, you get to attach nodes on cloud, on premises, on edge, into a single EKS managed control plane if you desire. And you get to offload all of the Kubernetes control plane management, and you get to have sort of a logical mapping of your infrastructure across all of these environments, providing you a better way to utilize your GPU resources wherever available, and to cost optimize as you go along as well. You can pick and choose which workload gets deployed in which environment based on the cost ROI benefits that you expect out of those workloads as well. So in terms of what we have seen customers do when they try to extend these platforms is, as I mentioned earlier on, integrate OSS solutions on top of it. Right? That lets Kubernetes do what it's good at, which is infrastructure orchestration, and you integrate OSS solutions on top, which provide you ML-specific functionality. For example, we've seen a lot of customers adopt Racer VLLM together with EKS that provides you a lot of functionality like memory and model optimization, multi-model management, request batching, query queuing, so on and so forth for inference infrastructure. So this can provide you a readily available inference endpoint or an inference stack that you can make available to your data scientists, that they can just deploy a model in and get an endpoint where they can run their inference out of. So in essence, to summarize all of this, when customers use EKS for generative AI, what they have been able to get is more control of their environment, to be able to customize it, to fit it to their specific needs, to be able to scale seamlessly to meet future demands, and be able to continuously cost optimize to meet their ROI targets. So with that, I'll hand it over to Mike to talk about the specific features that EKS provides.
Thanks, Rama. Okay, I'm going to do a bit of a rapid-fire overview of a lot of the features we've launched in the last 12 to 18 months to make it easier to run AI, ML, generative AI workloads on EKS. First, this is more a concrete picture of what Rama was just talking about, of all the tools out there that you can use to get started. There's really two parts. The open source stack, very rarely are you starting from scratch. In Kubernetes, Rama mentioned Ray, VLLM, Jupyter Hub. All of these tools work with Kubernetes, and it's really the flywheel effect that we like to talk about at Amazon, because if say you're going to try to author a new machine learning tool, you have a really good idea. If you want to get adoption of that, you're very likely going to make sure it works well on Kubernetes as one of your first deployment targets. And a lot of these frameworks, tools out there do just that. They work well in Kubernetes. Certain ones of these we choose to contribute to. We've made some contributions to Ray to make sure it works well with the Neuron frameworks. And then at the other end at EKS is we make sure that the infrastructure innovations and services at AWS that power this large-scale training inferencing work well with EKS. So CSI drivers, ECR, a lot of those foundational services that you need to use with ML workloads, we make sure they work really well with EKS. Okay, features. This one we don't give enough love to the work we do for scalability of the control plane. We rarely ever do a what's new post. EKS is a little bit more performant, but I know for a fact we have customers that created EKS clusters 6 years ago when the service launched, and they've just continuously upgraded then from 1.10 all the way up to 1.30. And those clusters look nothing like they did when they launched 6 years ago. So every time you create an EKS cluster, we're creating dedicated infrastructure for you. EC2 instances, NAT gateways, NLB. And we do a lot of work there over time to continuously add performance, whether it's newer instance types, faster volumes, better networking. And one of the projects we've done a lot of work on this year is changing the way we manage etcd to really get to much higher scale. We have certain customers that are asking us for 10,000, 20,000, 50,000 node clusters. And in order to make that happen, we've had to do some pretty major refactoring to the way we manage etcd, which is the backend database of Kubernetes. So likely next year, we'll publish some more on that, but that's something we've been working on. EFA is an example of a lower level infrastructure innovation that AWS, it's a OS bypass hardware interface that allows high levels of multi-node communication. We make that easy to use with EKS and Kubernetes with a device plugin. I think a couple notable recent enhancements, EFA just added support for cross-subnet communication. You used to be limited to a single subnet with EFA. Now you can do cross-subnet within the same AZ. You don't necessarily want to do training across AZs because that's expensive, but that helps with IP address exhaustion. And then the other thing that helps with IP address exhaustion is oftentimes your ML training workloads, they're sitting there just crunching, doing a lot of math. They don't actually need to talk to the internet. They only need to talk to each other, the other nodes in the cluster. So we recently added support for EFA-only ENI support, so you don't have to add actual IP addresses to the EFA devices in your cluster, and that's now supported on EKS. When you're running large-scale training jobs, you need a large-scale storage backend to handle all of the data that you're processing, and there's probably no larger scale storage backend in the world than S3. S3 open sourced a technology called Mount Point last year that allows you to mount an S3 bucket to an EC2 instance and use file system commands, and they get automatically translated to S3 object commands. And we've made that easy to use, again, with EKS via a CSI driver, Kubernetes native interface. Recent notable enhancement is the CSI driver added some more fine-grained access controls, so you can lock down which training pods in your cluster have access to which buckets. Generative AI training inferencing is not cheap. These instances are in high demand. They cost more than standard CPU instances. AWS has done a lot of work over the last 5 years to bring down improve price performance, lower the cost. Inferentia, Trainium, I think just yesterday we announced Trainium 2. And we'll continue to innovate at the lowest levels of silicon to make sure we give you the best price performance for training workloads. And again, these are great, but for those of you in this room, it's not helpful unless it works with EKS. And in the last couple of months, we've introduced accelerated AMIs for both Amazon Linux 2023, which is the newest general purpose Linux distribution from Amazon, as well as BottleRocket, which is our container-optimized operating system. These work with all of the various EKS compute options, self-managed node groups, Carpenter managed node groups, and probably, again, one of the underappreciated or under-talked about things we do here is the testing behind the scenes. The amount of drivers, frameworks, libraries, CUDA, toolkits, like all of these things that go into an AMI is complex, they change fast, and we have a pretty sophisticated testing framework where we're running training jobs, inferencing jobs before we release these AMIs, so you can just take them, run them, and be confident that they're gonna work for your workloads. Specifically for training workloads, I know we talk a lot about Carpenter these days, but managed node groups is our original managed compute product that we launched, I think 5 years ago at reInvent now. And managed node groups is actually a good fit for training workloads because often training workloads are not dynamic. You just have a large static pool of capacity that you need to run your training job. It's not going up and down often. So managed node groups is a good fit for that. And EC2 launched a feature a few months back called capacity block reservations. Again, I mentioned these instance types are in high demand. And capacity blocks is kind of like a hotel reservation system, but for EC2 instances. So up to 8 weeks in advance, you can book capacity for GPUs, and you know you'll have it at that specific time. Recently, they just gave the ability to extend the reservation, and that now natively works with managed node groups. So particularly for training workloads, we think this is a nice enhancement. GPU instances do tend to fail more often than CPU instances. They're running complex math calculations. I know the EC2 team is doing a ton of work, at the data center level to try to increase the performance. Things like, 1% changes in humidity in the data center can give a 10% increase in the lifetime of a GPU instance. But they do fail on occasion. And we've put a lot of effort this year into detecting those failures so you don't have an instance that goes bad in your cluster and is wasting money while it's not actually doing any work. So this actually rolled out for EKS auto mode just this last week, which I'll talk about it in a minute. It'll be rolling out for other compute over the next week or two. But it's really two parts. It's the node health monitoring agent, which is an agent that'll run as a daemon set in your cluster, look for all kinds of issues. We have 6 years of experience of running lots of Kubernetes clusters. We've seen every possible way a node can fail. And we've taken that knowledge and built it into this node health monitoring repair agent with a specific focus on GPU instances. And then on the auto repair side, managed node groups will get the auto repair functionality where you can opt in to say, okay, EKS, you detected an issue. In some cases, maybe you want to recycle the instance. In other cases, maybe you want to reboot the instance depending on the type of failure. And that'll be rolling out very soon. And then my last slide is on monitoring observability. I think it was at reInvent last year we launched version 2 of CloudWatch Container Insights, which it's a lot better than V1. If any of you tried V1 a couple years back, had its challenges, the new version of CloudWatch Container Insights is really, really nice. It's also more cost-effective for container workloads. And a recent enhancement to the Container Insights plugin, and you just run this as an agent in your EKS cluster, is it now automatically includes the monitoring plugins for both NVIDIA and Neuron instance types. It'll scrape those metrics, send them to CloudWatch, allow you to monitor how efficient your GPU resources are consumed, do things like understand how workloads are running, figure out how to tune hyperparameters. There's a lot of work that the team did there to make sure that you have a simple out-of-the-box checkbox GPU NVIDIA monitoring experience. So highly recommend you check this one out if you haven't seen it. Okay, I want to talk specifically about inference. I mentioned at the beginning 2024 is the year of production. And production generally means inferencing. If you have a live workload, you're serving requests to your customers. And that brings challenges, especially with these large language models. Running inference at scale can be complex. How do you serve models that are cost effective, that have the performance you want, latency, throughput, availability, all of these become concerns when you're running inferencing at scale. And how we're thinking about inferencing at EKS is really, there's those three measurements on the left. The throughput, how many tokens per second your model is serving, the latency, which is the time to the first token, and then cost, which is really the GPU compute utilization, how much of the GPU you're actually using. And so a lot of these features we're building and framework enhancements we're doing are designed to help you achieve that trade-off between throughput, latency, and cost. There's never going to be a perfect answer, but we want to give you the tools to make it easy to do that trade-off for yourself. Scaling to zero, scaling up quickly, optimizing ML container images. This is something we're doing quite a bit of work in the Containerd project. Oftentimes these ML images are tens, sometimes I've seen hundreds of gigabytes. And when you start your instance, you don't want to wait 15 minutes while the instance is costing you money and the image is being downloaded. So we've done a lot of work there to speed up that. I just talked about minimizing hardware failures. And then we're doing a lot of contributions in the open source space to make sure that a lot of these popular frameworks do work well on EKS. And speaking of them, Ray, VLLM, these are two of the, and even in the last 2 days in customer conversations I've been in, I've heard these two projects mentioned more than any others as the ones that customers are now using to serve inference workloads in production, using things like the device plugins, EFA, NVIDIA, Neuron, accelerated drivers. All of that is a very common infrastructure stack that we're seeing customers use for inference with EKS. Oh no, what happened? Okay, I don't know what's happening there. Anyway, we'll skip. Ram already talked about Carpenter, but Carpenter really is the tool that, especially for inferencing, I mentioned managed node groups is good for training. Inferencing is generally a much more dynamic workload. Carpenter is a good fit there because it can help you more easily take advantage of the breadth and depth of EC2 instance types. In some cases, you may want to use Graviton instances for inferencing. Maybe you don't necessarily need to use GPU instances. Carpenter in general, we're seeing a lot of success with customers do for inference workloads. And hot off the press, some of you maybe saw announcements over the last couple days, but we introduced what we're calling auto mode the other day. And part of auto mode is integrating Carpenter into EKS, making it easier to use. Auto mode is really the new easy button for the Kubernetes data plane, the compute, storage, networking that you generally need to run in your cluster. Now is included by default in EKS. And I'm specifically bringing it up in this presentation because of the Carpenter angle. Carpenter is good for inferencing. It's now built in by default. Some of the three things on the right, compute optimization, cost efficiency, supporting diverse workloads, that's really built in Carpenter. That's what it's doing. The interesting innovation that we did with auto mode, if you haven't been to any of the presentations yet, is we have this new operational model with EC2 where previously you had two ways of running compute in AWS. You had the fully managed Lambda Fargate model where compute's running in a AWS owned account, or you had standard EC2 that was you owned. This new model, EC2 managed instances they're calling, is in the middle of that, where it's an EC2 instance in your account, but an AWS service like EKS actually owns the lifecycle of that instance. So if you go to try to delete an ENI, delete the instance, you'll get an error that says in use by a service, and you have to use that through EKS. And I bring it up because I think especially in the top right here, the capabilities, a lot of the hard parts of getting started with machine learning workloads on EKS, which is figuring out the right device drivers, the EFA plugin, configuring instance storage. If you have local disk instances, customers used to have to do these really complicated user data scripts to set up a RAID 0 volume on the instance. A lot of that is now fully automated with EKS auto mode. So we automatically configure RAID 0. We automatically configure the device plugins, whether it's NVIDIA or Neuron. We already include if you launch a GPU instance, we're going to pick the right AMI that matches that instance. So just there's a lot less work you have to think about For training workloads, I'm not going to quite say auto mode is a great fit yet. There's a 21-day max instance lifetime. A lot of times we talk to customers who are running training jobs that go for months in some cases. But I think for inference workloads, for production, running models in production, auto mode could be a good fit. Just an example of a pretty common stack that we're seeing, and again, this is validated in the last 2 days of conversations I've had with customers. But using Ray, VLLM, and you're using Carpenter, which is going to spin up a standard CPU instance to run the head pod and the KUB314 operator, and then it's going to spin up, for example, inferentia instances to actually run your serving workloads. So this is a more and more common pattern we're seeing for customers actually running inference workloads in production with EKS. And then finally, just a few more customer stories, H2O, OMI Unitary, all of these customers, I believe these are all either case studies, blogs you can go read about. They've all moved to Carpenter to do their inferencing workloads. I think H2O is an interesting one. They're using BottleRocket to prefetch container images. We have a nice blog out there that shows you how to do that. I mentioned the 15-minute time it takes. Yes, we can optimize that, but the fastest way is actually just going to preload the container image on the instance itself, which you can do with BottleRocket quite easily now. And other ones, yeah, just using Carpenter, reducing costs. We've seen a lot of these customers have success moving to Carpenter to do their inference workloads. Okay, I will hand it off to Kaz to talk about one of those customers, who is one of those customers who's been successful with EKS.
Cool. Thanks, Mike. Hey, everyone. I'm Kaz Starziak. I'm a product manager leader at Eli Lilly and Company, and I focus on research and AI products. And just going to share a little bit from a customer experience of building Gen AI capabilities on EKS. And I thought to start, I could just talk a little bit about the tech evolution at Lilly and maybe help explain why someone from Eli Lilly is on an EKS Gen AI track at reInvent. I'll talk a little bit about our platform development, including EKS, and then the Gen AI scale-up that's underway. So just a little bit of historical context. The pictures here tell a little bit of Lilly's history with technology. On the left, it's actually 1987 and some classic 80s corporate executives very excited about the most recent delivery of some personal computer technology. And then on the right, some of you might know what that is, or you can see the text there. It's actually a Cray 2 supercomputer. And in 1989, Lilly was the first non-governmental organization to purchase one of those in the US. And I just share that because after joining Lilly a year ago, I was pleasantly surprised to learn about this history of early technology adoption and innovation that I didn't expect to find in a 150-year-old company. And there was the software development and the data science and everything else that came along with adopting those technologies. Now, unfortunately, it was not just a upward trajectory from there, similar to the so-called AI winters that that industry has gone through. We had some of our own kind of technology innovation winters. And it really started around 2001 in what internally we call year X. And that was the year that the first Prozac patents started dropping and going off patent. And at the time, that was actually a third of Lilly's profits. We had some other medicines that went off patent. And you can imagine as sales come down dramatically, there was a lot of examination of costs, bringing down costs, and things that were quote unquote non-core, like software development and some of that technology innovation was very hard hit. And so there was this long period where I think some of that early innovation started to atrophy a little bit. But you flash forward to today, and it's completely flipped. And there's a recognition across the company that we really do need to become a tech company to continue succeeding as a medicines company for years and decades to come. And thankfully, we've been successful with some of our recent medicines. We have a very strong pipeline, and that's enabling us to invest. And there's been significant investment and growth in those tech capabilities, software engineering capabilities, robotics, automation, data science, all types of AI. And there's much more of that coming. And one of the things we're doing as we're going through this evolution and making these investments is really trying to adopt most of the modern software development practices. And part of that is a team was formed just a couple years ago that I'm part of. This is the software product engineering team. It's led by a former Apple engineering leader, Gokul Radhakrishnan. And this team really focuses on building scaled products and platforms that are going to be high reliability, high usage, and we try to take an approach that's really a kind of software engineering center of excellence to help demonstrate and kind of spread those practices across the developers at Lilly. And a big part of it is this platform approach where we're thinking about shared libraries, reusable components. We tend to leverage a lot of open source capabilities and tools and doing things like building broad observability tools that can get used across the organization. And one of the platforms that's been a really big investment for us is this KATS platform. And so this is a cloud applications and technology as a service. And what this is a comprehensive cloud application development and hosting solution. And so we built this on AWS, and we use a series of open source and AWS managed services to support it. And this is a highly simplified diagram. But some of the key points, we use EKS for Kubernetes management. We use EC2 and Fargate for container execution. And we have other AWS services integrated into it, like S3, RDS, Secret Manager, a whole slew of things. We also do GitOps CI/CD automation, so teams can go kind of seamlessly from commit to production. So kicks off with GitHub Actions, Docker image push to ECR, Argo detects and then automatically puts that into the right Kubernetes environment. And so, what this means for developers, it's really been a newer way of developing as we've shifted to the cloud. They get a lot of speed and efficiency. So they don't need to make a bunch of infrastructure decisions, let alone build that infrastructure. Kind of laid out a menu for them to get started. And then they obviously have the speed of that automated deployment. So that's been a big part of our kind of tech transformation evolution to the cloud, and it's gotten significant usage. It also brings security. So we have a lot of standardization, and we kind of lay some tracks that we get people to follow, and so that gets them into robust security practices. We have vulnerability scanning. We've also provided observability tools. So some of those with the Amazon services. We also use some open source tools like Loki and Grafana, so that teams building on this, they get a lot of logging, alerting, reporting, visualization that can help them manage their applications as they scale. And that last part's really the biggest benefit, is the scale and reliability. So once an application is developed here, it can scale up to all of Lilly's workforce. It can scale up globally, and there's really no additional work for the team, and it maintains high reliability when it does that. So as I've mentioned, we've seen significant adoption over the last couple years on this platform. We've got hundreds of developers using it. We've got growing number of applications, growing number of commits, increasing exponentially in global deployments across many countries. And one of the metrics I like, I sat in the intern end of summer readouts, and it felt like almost every intern mentioned KATS, using it, and how it helped accelerate the development of whatever their intern project was. So I think that's a good measure of its effectiveness. And so you can imagine some of the increase in usage of this, a lot of it is coming from Gen AI, and we've been making big investments there. And just to give you some context, really what Lilly's looking to do is lead our industry in terms of pharma peers in the adoption of and impact from Gen AI. And we do think it's fundamentally transformational to a lot of the work that we do. And we've already been investing in it. So Lilly actually has a history of using AI for drug discovery, small and large molecule tools for generating and screening. And there's actually a pretty solid data science team that's been doing NLP work before all the LLMs came out to do things like clinical summarization. So there's a history of that we're building on, but we're really going all in on Gen AI. And we're working with the hyperscalers, we're getting out-of-box solutions. We're working with smaller companies, startups for more organization or use case specific solutions. But then we're also doing a lot of internal development. And as part of this tech transformation we're going through, we are looking where does it make sense for us to have some of those capabilities internally. And some of that is use case and proof of concept. But really, we try to focus on what are scaled products and platforms that can serve the company. And one of the platforms that we decided to build was a broadly usable developer-facing Gen AI platform to help accelerate that work at Lilly. And I can show you a little bit here. So we knew Gen AI is going to be big. We wanted to be reliable. We wanted to be able to scale large number of users globally. So we decided to build it on top of that CATS platform that I just walked you through. And we put together these main components. And we started this development in 2023. We had our first production release in December. And we've been adding features and capabilities as we've gone through the year. At the foundational level, it's a model library. So we want teams to be able to choose from the latest and greatest LLMs. And we're constantly updating it. We're big fans of the Anthropic line of models, but we also have OpenAI, Gemini, Hugging Face, Llama. You can deploy pretty much any model from Hugging Face if you get the legal approval. And we allow teams to choose. You can host those as retail. We have open source. There can be fine-tuned models. You can host them locally in our GPU cluster. And then on top of that, we built orchestration tools. So it started fairly simple, and we use LangChain as our main orchestration framework. And we started fairly simple with some tools for prompt engineering and model chaining. And we've added in more and more complex orchestration tools, and you can now support agentic workflows and multi-agent systems with it. And then we have tools for operations, scaling, and maintenance. So we try to take care of a lot of the scaling that the teams are going to need, so they don't need to worry about it. So our central team has an ops team thinking about provisioning capacity. We recently worked with the AWS team to help optimize some of our cross-region inferences and our rate limiting capacity to help get better performance at scale, lower latency. And so we're kind of doing those things centrally so that other teams don't have to worry about it, as well as quality and monitoring. So we've created various eval tools so that teams, as they're scaling up, can monitor for drift, or if they want to assess the latest model, they can easily check how performance changes. We also have data integrations that they're specific to the Lilly environment. We're always trying to add new ones there, and information retrieval tools. We started with a fairly kind of vanilla semantic search capability vector database, and we've been adding in more complexity. We made elements of that tunable, so if teams want to optimize things like chunk size and overlap, they can get in there and do that. And then we started adding other things like contextual chunking and hybrid search, and continuing to improve the information retrieval. So again, teams don't need to go out and build that. We have it kind of optimized to the Lilly environment. And all of it's wrapped in this oversight and compliance and security layer. So we have full input-output logging. Cyber has visibility into that, into all of the model configs, all of the users. We also have scanning and alerts. It's configurable by our cyber team. We use some AWS tools as well as some open source tools to do this. And it helps give a lot of reassurance to our cyber team and actually kind of points this as a preferred platform. And so what that has allowed us to do, again, we've been able to accelerate development, so teams are able to get started very quickly and get to POCs and MVPs quickly. They have optionality, so you heard the guys earlier talk about the importance of different models for different use cases. I think Andy talked about it in his keynote yesterday. And so teams can easily switch back and forth and figure out which model is right for their use case. I mentioned quality, security, compliance built in. And then because we've built this on AWS, on EKS, it's very scalable. So we've had use cases that have gone from small early testing to deployed globally without having major issues or downtime and not requiring a ton of work from the teams actually doing the development. And so we launched it originally into production in 2023 in December. So it's been less than a year, and we've been impressed with the uptake, and it's really impacting every part of our business. And we see this transformation happening. Just some examples. Probably my favorite one is this agentic discovery assistant. So there is a cheminformatics agent. It has access to about 20 different tools. Some of those are cheminformatics tools. Some of them are internal databases with Lilly molecule information. They're external databases. And we have an LLM that's answering questions or executing user prompt workflows and choosing which of those tools to use. And it allows these very powerful workflows to be executed that can aid our scientists in early stage discovery. We have things in the clinical trial space, so helping with how we respond to regulators. We get thousands of questions and have to answer those from regulators all over the world. It's a natural thing for LLMs to help us do. We have tools in our manufacturing space. So we have global manufacturing. There's a huge focus on our manufacturing line uptime. And so we have this assistant that's been developed using this platform that uses structured and unstructured data from like SOPs as well as equipment sensor data to help us, our line operators monitor and manage uptime. There's claims drafting tools, and we're even developing our first patient-facing Q&A tool on the platform. So it's exciting to see that adoption. And then in terms of results, we've seen the acceleration. So we've heard it anecdotally from teams, and then we've seen teams, in as little as a few weeks, they're able to get a POC out there, or in a few months actually have an MVP that's pushed into production because they have these tools ready and available. We're able to meet quality, security, compliance. It's really become a preferred platform from our cyber team, and they encourage folks to use this because we have all of that visibility, logging, and alerts. And then it's enabled rapid scale up, and we've seen a lot of adoption. So we have over 500 developers at Lilly using the platform. There's thousands of end users in over 30 countries. In a given month, we have billions of tokens that are processed by the platform. So the scale has been what we were hoping to see. And it's supporting this Tech at Lilly evolution. Obviously, we're building products on top of it that are impactful. But because of the work we're doing, it's also this kind of virtuous cycle of attracting and retaining talent that wants to work on this. And it's kind of supporting that transformation I was talking about. And lastly, just to close, some lessons learned. I would say the main lesson is our kind of belief and intuition that having this platform approach. So using a scalable platform, like EKS, building this somewhat opinionated approach to Gen AI development, it's worked. And we have developers using it. It's accelerating it. We're seeing things scale. We're seeing things move into production. So I think that's probably the biggest lesson learned. But some of the other things along the way, if you build it, some will come. So when you build a platform like this, you're going to have the few early adopters that just naturally just start using it. Especially in a place like Lilly, you'll have kind of that top of the curve, really capable, fast-moving developer teams. But then there's a whole distribution curve after that. And if you want to get more adoption, there's a lot of work around evangelizing, answering questions, getting support documentation out there, getting support teams. Product mindset. So we've really treated it like a product. We have a product manager, a roadmap. We're really always trying to gather voice of customer to make sure. We might be very excited about building, the latest incremental improvement to the information retrieval pipeline, but our customers are like, I just wish your QA environment was a little more stable. And so making sure we don't get too lost in the engineering and technology of it, but stay grounded with the customers has been important. And then expectations increase rapidly. So initially, there was skepticism, and it's like for some developers at Lilly, this is like a new approach, kind of channeling them into a certain a platform and putting some constraints around it. But the skepticism quickly turned to like, oh, I see, it's speeding it up, it's making it easier, I get the approvals, and we're seeing adoption. And then it turned to like, oh, now I want this, where's the documentation, what are your formal SLAs? So I'd say if you're taking this approach, make sure to think ahead of it. And if you're building the platform, keep up with the documentation, keep up with the support, get ahead of, communicating SLAs, because especially in a place like Lilly, we have patient-facing stuff, we have manufacturing stuff, there's 24/7 expectations. And then lastly, I mentioned the cyber partnership. And investing in that early was pretty key, I think, to this platform's success, especially in a company like Lilly, where there's a high bar around cyber, privacy, legal, and all of that. So with that, I think I'll turn it back over to Rama.
Thanks, Cass. Appreciate you taking the time to share those awesome insights with us. So something we have talked a lot about throughout this presentation has been that customers want to integrate OSS solutions on top of EKS to achieve the desired ML functionality. So a lot of our customers were asking us for guidance around how to get started quickly integrating these solutions, what are the best practices for integrating them, can you provide us some templates and patterns that you're seeing success with. So that's why we launched the Data on EKS project. It's an open source project where we publish different Gen AI patterns that we have seen across our customers. We publish blueprints, patterns, Terraform templates that you can use to easily get started integrating some of the popular OSS solutions that we see getting integrated with EKS for solving those ML specific challenges. So we have launched a number of these patterns over the last year. We continue to raise create more patterns as we see success with those patterns in the real world. We have been placing special focus on releasing inference specific patterns on top of EKS. Some of the things that we have recently released are NVIDIA Triton with VLLM, Racer with VLLM, NVIDIA NIMS on EKS, so on and so forth. So check out our data on EKS website, where you'll see a lot of different patterns for inference and for training and fine tuning as well. With that, we have almost come to the end of it. There are some interesting sessions that are coming up with EKS, Amazon EKS infrastructure as code, GitOps session on that as well, and there is an interesting session from S&P Global that have implemented GenAI on EKS and how they are scaling to meet millions of inference requests per week using that setup as well. And we also have the future of Kubernetes on AWS session coming up tomorrow that you can check out. You can continue your Amazon EKS learning through some of their resources available out there, through workshops, through getting digital badges and best practices guides as well. With that, we come to the end of the session. Thank you for listening to us patiently, and if you have any questions, we'll be hanging out outside the room for some time. You can approach us and we can answer any questions for you as well. Thank you.